Hello fam, I hope you're well, I hope you're good. If you're not, as I always say, take one day at a time. But Fethu, don't forget to invite God in all that you do. As I always say, Fethu, do not stop praying. The Bible says, let us not stop praying. You get what I'm saying? Whether things are hard, whether things are good, let's not even forget to do that. Let's not even forget to give God all the glory. You know what I'm saying? We are nothing without God, Fethu. Thank you so much. Now, today I want us to look at the difference between ionic substances or ionic compounds and molecular compounds. You know, under aqueous solution and the physical chemistry as well. But this is just the basics for grade 10 and stuff, you know. And also the 11s and the 12s, they can also still be able to check these ones out, you know. So some people do not know this type of terms, which we call dissociation and dissolution or dissolving, you know. So the term dissolution is the same as dissolving. So we say that a process in which ionic crystals, they break up into ions in water, which I wrote as H2O because of the space is not really enough for me, so I had to put it in like that, you know what I'm saying? So dissolution or dissolving is a process in which ionic crystals break up into ions in water. That is what you call dissolving or dissolution. Now, there is something called dissociation. We say that is a process in which ionic compounds separate into smaller ions. They separate into smaller ions. There is a bit of similarity there, of course, but these two, they're not really the same. I'm gonna show you. Usually the best way for me to show you this is practically by making use of experiments. That's where you're gonna be able to see dissolution and dissociation. You get what I'm saying? But yeah, okay, it's fine. There is also another term called hydration. Hydration. Maybe I must just write it down. Hydration. 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 But if you already know what's a basically in hydration, you're good. You know what I'm saying? So let's talk about hydration. Hydration is a process. Is a process in which ions become surrounded by water molecules. So a process in which the ions become surrounded by the water molecules, we call that what? Hydration. All of these three, basically, there's a little bit of similarity. And another thing is that whenever the process is taking place, whenever the reaction is taking place, all of them, they are all taking place, but one at a time. You get what I'm saying? So yeah, it's like a simultaneous equation at some point. It's like a simultaneous equation. So whenever this ion starts to become, starts to break up into ions in water, it's because of they'll be dissolving, right, in that water. And now the thing is that the minute you dissolve that substance, is going to be surrounded by the water molecules, and then it starts to break. Then each and every ion, it's going to have its own water molecule, like H2O, 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 H2O. It's so good if you see the experiment of it. Like, it's so good if you see the experiment of it. So next time I'll be doing this practically in the laboratory so that you guys can see, right? All right. But yeah, I'm gonna also share some links to show you guys the beauty of the chemistry. You know what I'm saying? Because chemistry is more beautiful and more understanding if you are doing it practically, not only theoretically. You know what I'm saying? Because some, even when I'll be trying to show them, they might not really get it until I have to perform an experiment to make them understand. You get what I'm saying? Okay, all the best guys at the end of the day. Now, let's talk about something which is important under aqueous solution. Because here's the thing, people do not know the difference between an ionic compound and a molecular compound. All right. If you guys did, what do we call this? Bonding, chemical bonding. You will remember that a chemical bonding is basically formed when two or more atoms they share electrons, or there's a transfer of electrons, and those atoms are also held by the forces of attraction and stuff. you know, and the two types are basically we have three types of chemical bonding. We have ionic bonding, we have covalent bonding, we have metallic bonding. So what is the difference between those three bonds? Because if you cannot understand this type of bonds, you'll also be able to, I'm telling you, you're going to struggle here. So here's the thing that I can try to mention to you guys. Number one, under ionic bond. So ionic bonding, we say that this one is the transfer of electrons between two atoms or atoms, is the transfer of electrons between two atoms. Okay, so basically this bond of ionic, it requires a metal and a non-metal. In other words, for us to can be able to have a chemical bond, I mean an ionic bonding, to form an ionic substance, to form that ionic compound, we need a metal element and a non-metal element. And then we're going to be able to form an ionic bond where there's going to be a transfer of electrons. You get what I'm saying? All right, good stuff. So some people might not really understand. Guys, let me give you a picture of something. Just look at your periodic table, all right? On your periodic table, there's a... Give me a moment so that I can show you what I'm talking about, because some people might not really get this. All right. So here is a periodic table. I hope you can see. Right, guys, on this periodic table, as you can see, this group one, this that has the like blue color thing, we call it the alkaline groups, right? So the alkaline or the alkali metals, and then group 2, which is the one of beryllium, magnesium, calcium, strontium, barium. You know, this one, it's a group of alkaline earth metals, and then these ones here on the middle, there's like more scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. And going down there, including both platinum and both mercury and both gold and stuff. These are called transition metals. We call them the transition metals. You get what I'm saying? So I will teach you about transition metals, because these elements, they are kind of like crazy on the periodic table. We have monoatomic ions, polyatomic ions, transition metals. This is part of inorganic chemistry in a way. All right? And then you have like both boron. This is where there's a little bit of complex, because there's a mixture of metalloids, which we call them the semi-metals, like your silicon, your germanium, and also arsenic there. You can see boron. And then you have carbon. Carbon is the non-metal. And then you have group number 5 here, which is nitrogen, phosphorus. Group 6, oxygen, sulfur. Group 7, fluorine, chlorine, bromine, iodine, and stuff. The last group, which is group 8, linearly, which are group 18, which is still fine. And helium, neon, argon, and stuff. So the thing that my goal here is to show you guys where metals and non-metals are. Okay. So mostly on the periodic table, if you want to understand the periodic table, is that on this is my right? On our right, we have metals. Metallic, basically the metallic increases from left to right. So on my right, that's where we have metals. And then on our left, that's where we have non-metals. We exclude group 8, because group 8, we call them the noble gases. They are inert, they are non-reactive. They don't really react because they satisfy the octet rule, which I will talk about it next time. And then there's only one element in group 1, which is if you can see, it's a hydrogen. Hydrogen is a non-metal. which it was like allowed to be in group 1, which I'll tell you why, the exception of why is in group 1 next time, not today. Okay, yes. So in a way, people might struggle to find or to form ionic substances or ionic compounds, but you don't have to struggle, because you already know that metals are like lithium, sodium, potassium, cesium, rubidium, and friends. So calcium, and those are the metals you know already. If you see any of the nonmetals like boron, oxygen, nitrogen bonding with any of the elements in this group, you should know that that is what we call an ionic bond. Okay, but hydrogen, as I've said, guys, it is a nonmetal. So even if you see hydrogen reacting with both chlorine and stuff, it's not an ionic bond, okay, because it's a non-metal. So I hope I was able to assist you. And the last thing that I would like to mention to you guys is that we have acidity and basicity. So the acidity increases from right to left. So most of the elements that are acidic, they are this side. Most of the elements that are basic, basicity increases from left to right. And it also increases when you go down. You get it? And the acidity also increases when you go down, like, you get it? But yeah, that is the trends that you guys should know under the periodic table. You must know what is electronegativity. You must know what is ionization energy. You must know what is electron affinity. Know those type of stuff, or enthalpy change and stuff. Ne? But yeah, for now, let's continue so that you guys can have a clear picture. Guys, if I have this, because my goal is to help people to understand the difference between ionic compounds and molecular compounds. All right. So here's the thing: under ionic bond or ionic, how can I remember? I gave you the definition of ionic bonding. That is a type of a chemical bond that occurs between a metal and a non-metal, and there's a transfer of electrons. That's number one. Number two, what are the examples? Remember, you need to learn to take your metal and a non-metal to make a bond. Let's do some examples. If I have magnesium 2 plus oxygen 2 minus. Okay, now here's the thing. Everyone who's in group 2, they'll have a plus charge of 2. Everyone who's in group 1, they'll have a plus 1 of, okay? Everyone who's in group 6, like oxygen, sulfur, they will have a 2 minus. And then that 2 minus means that oxygen needs 2 electrons to be stable, because oxygen has already 6 on the valence, the valency. The valence electrons are like 6, so it needs 2 more electrons to be stable. You look at what chlorine, what bromine, iodine, fluorine, they have a minus 1 charge like this. You ask yourself why? It's because they need that 1 electron to be stable. Those argon, helium, they are already stable. They have that's why they are hardly bonding and stuff. They are non-reactive. So this one needs, they are 7. So I need 1 electron to be stable, like having 8, like one neon. You get? So this is one of the things that you guys should know, but it's part of inorganic. Those are in varsity, those are in college, or those are doing advanced chemistry. But here's the main thing that you guys should know. Right now, I need to form an ionic compound, an ionic substance. So if I have a magnesium and oxygen, there is something called ion exchange. There is something called ion exchange. Ion exchange. What is an ion exchange? Ion exchange is a reaction in which the ions, the substances basically exchange their ions in a way. The elements or the substances, they basically exchange their ions in a reaction. So you have a reaction of magnesium and oxygen. What's going to happen is that these 2 ions, since they're kind of like the same, they will cancel out each other. You'll have a molecule like this, MgO. You have a compound like this, I meant to say. So this is your compound. What happened? The 2 plus and the 2 minus, they had, obviously 2 minus 2 is 0. So they had to balance out each other. That's what happens in this case, right? So we have magnesium oxide. This magnesium oxide, it is an ionic compound because magnesium is a metal, oxygen is a non-metal. So this is what we call an ionic substance or an ionic what? Compound, right? Let's give another one. The one in which maybe we'll have a better ion exchange you can see. Let's call chlorine. Okay, there you go. Now, since these ones are not the same, check something. The charges are not the same. Since the charges are not the same, there's gonna be an ion exchange. Whenever they're the same, like 2 plus, 2 minus, they definitely like cancel out each other. But if they are not the same, they will exchange. The 2 will come to chlorine on the bottom, and then this one will be here, which you will not really see. This is my point. You'll have what you call magnesium Cl2. What happened there? The 2 comes from the magnesium, and then there's just 1 which comes there, which doesn't really matter that one. So this is what you call magnesium chloride. They will give you the chemical name to say magnesium chloride. What is the chemical formula? This is a chemical formula, magnesium chloride. Or they say, give us the chemical name. Magnesium chloride. We call this magnesium chloride. It's a chemical name, and it's an ionic substance, an ionic compound. I hope you guys have a clear picture of what an ionic compound or and you get what I'm saying? Yeah, all right. Then, one of the easiest of them all that people know is this one. Which one can I do? Just give me a sec. Let me do calcium for now. Let me do calcium. Ca is 2 plus. Can I use a polyatomic ion? If I use a polyatomic ion, I can use carbonate, CO3 2 minus. Okay, so now check something. Since these two, they have the same charge but opposite signs or opposite directions, it's 2 plus 2 minus. They cancel it out, and then you're going to have what you call calcium carbonate. That's what you're going to have. So it's a calcium carbonate. You get what I'm saying? Calcium carbonate. So you ask yourself, how did they form this? It's because of this one comes from group 2, which has everyone in group 2, they carry a 2 plus charge. Everyone, and then you should know the polyatomic ions like sulfate, phosphate, nitrate, nitrite. You should know Please guys, go and study what are polyatomic ions, okay? Go and study those things. All right. And then one of the things you must know, okay, maybe I can use phosphate now. Let me see if we could use phosphate, which is like PO4 3 minus. That's a phosphate, calcium phosphate. So what's going to happen, you see, they don't have the same charge. There's going to be what you call ion exchange. So I'm going to have what you call Ca3 and sorry, I made a mistake, my bad. PO4 2. Yes, I'm really sorry for that. So it's supposed, because remember the 2 is gonna accommodate even phosphorus and stuff, you get it? So so that's what you call calcium phosphate. You call this guy calcium phosphate. Calcium and phosphate. So calcium phosphate, the 2 goes to the bottom of this phosphate, and the 3 will go to the bottom of calcium. That's what you call ion exchange. So I hope you are able to see or to learn what ionic bond or ionic substances or ionic compound are. Ne? Okay. The easiest one that I want you to show you is this one, guys. Is this one. It's easy. We call this guy sodium. So I take one of the elements in group 1, which is called sodium, and I take one of the elements in group 7 called the chlorine. So when these two people meet, or they in a reaction, they will form what we call sodium chloride. Sodium chloride. So this is what you call sodium chloride. Yes, people call it table salt, a common name, a table salt. Yes. So this is an example of an ionic bond. This is an example of ionic substance, ionic compound anyway. I hope you guys are able to can now make your own ionic substance, ionic compounds. You get it? Every time take a metal and a non-metal, you will basically create what you call sodium ionic substance or ionic compound. Okay, good stuff. Now let's go to what we call a covalent bond. Guys, a covalent bond is a type of a bond in which there is a sharing of electrons. Here we talk about sharing of electrons between two atoms, but I'm just going to say between two nonmetals. Between two nonmetals. Just to can summarize the best definition for you guys. Yeah. Covalent bond is a type of a chemical bond in which there is what? Sharing of electrons between two nonmetals. So in a way, this one takes place between what? Nonmetals. In ionic bond, you have a metal and a non-metal. In covalent bond, you must have two nonmetals combined together. They will definitely form what you call a covalent bond. All right, good stuff. Now, we have two types of covalent bond that you guys must know. Let's talk about them. Two types of what? Covalent bond you must know. We have one polar and two non-polar. People do not know what a polar bond is or polar molecules are. You get? And remember, you now know what are nonmetals like, right? Okay, we do. So this one, in the under polar, we're gonna be talking about unequal sharing of electrons. Here we're gonna be talking about equal sharing of electrons. You want to know the difference between the two? I'm telling you. Here we're going to talk about equal sharing of electrons. So, if you want to look at the types of chemicals, the types of bond or types of molecules that are taking place, or for you to identify, excuse me, this one is going to be unsymmetrical. Unsymmetrical, and this one is going to be a symmetrical shape. This one is symmetrical. I'm going to give you examples of these ones I could give you now. Just now I'm going to give you. All right. So a polar covalent bond or a polar covalent molecule is a molecule in which there is an unequal sharing of electrons. So when those two elements they are sharing electrons, the other one has the upper hand. Like we are sharing, yes, but let's come to my side. You get what I'm saying? Instead of let's all be mogari, like let's all be in the middle, the other one will be like, no, you come on my side, because they have basically the reason why there is unequal sharing of electrons in this case of polar. We look at or we consider what we call electronegativity. What is electronegativity? Electronegativity, it is the tendency of atoms to attract electrons to itself. All right. So if you look at your periodic table, atoms or elements that have the highest electronegativity, they are on the left and also on the top of the periodic table, because it increases from right to left and from the bottom to the top. Okay. So that's why you look at these elements, they are always minus, they are always negative. It's because they like to pull, they like to take. You get it? They have the highest electronegativity. So that's what happens in terms of here. So if they all have that equal electronegativity, they will tend to be non-polar. You get what I'm saying? Because there is no boss in that case. And another thing is because of the values of the electronegativity. If it gives you 0 or is less than 0.5, it's non-polar. If it's 0.5 going up, maybe until 1, until 0.9, it's polar. Because from 1 going up, it's ionic bond. Yeah, my goal is not to touch on those things. It was just for me to try to give you the picture, because you come across this type of things and you don't even know what to do. All right. So let me give you guys examples of these two, and then we move on, because this is very much important. Now, antipolar, you can have something like this, and then even H2O. Here you can have like CO2, your carbon dioxide. You could have like H2, you could have like Br2, you get, okay? So these are like the examples I could give you. So here you have symmetrical shape. This is what I'm talking about. People do not understand. Guys, look, I'm drawing the structure for you. Let me show you with carbon monoxide. Oxygen is partially negative, partially positive. Partially negative, this one. Partially negative, partially positive. What is the goal of this? The goal of this is to show you what we call a dipole moment, which measures the polarity of a molecule in a substance. So you want to check which one is more electronegative. It's oxygen. Since oxygen has more electronegativity than carbon, it's going to pull those electrons. They are all nonmetals. This guy is going to pull electrons towards itself to say, come. So you're going to have something like this. You get? And then you're also going to have something like this. So this other oxygen, because of their two, is also saying, Remember, carbon has 4 electrons. And oxygen likes to form 2 bonds because it needs to be stable. So I will talk about it when we are doing molecular structures and stuff. For now, I just wanted to give you guys the picture. All right. So these guys, at the end of the day, if this is 1 minus 1, this is plus 1, they will give you 0. So basically, 0 dipole moment, it means that there is no polarity in this case. That's why this molecule tends to be non-polar, because of it's a symmetrical shape. There is equal sharing of electrons in a way. Here, this guy is going to pull towards itself like this. See, they are all going in one direction, the electrons. They are all going to one. So here, it's like unfair sharing. There's an unfair sharing, unequal sharing. So unequal sharing makes a molecule to be polar. There is a dipole moment there because the molecule is polar. So that's what we mean when we say polar and non-polar. We'll talk about it next time, okay? And of course, this, as you can see, it's a molecule. It's a molecule. It's a molecular compound, because they are all non-metals at the end of the day. So now let's continue. Okay. So guys, let me just put this on. So guys, here's the thing. You look at this guy, CH4. You tell me, is this guy an ionic bond? No. Remember, when you see non-metals all combined together, we talk about a molecular compound. You get it? Which are covalent bonds at the end of the day. All right. So you can see it's a molecular compound, Right. So now let's get to the business of the day, because the goal is to understand the difference between ionic substance, molecular substance, and how to form them. Okay. So I have some questions for you guys, or questions for us, so that we can do them. So just give me a little moment and we're going to do them together. All right. So the question says, for each of the following, listen, for each of the following, say whether the substance is ionic or molecular. So we're going to talk about number 1. We have KNO3. Number 2, we have C2H5OH. 3. We have C12H22O11. Number 4, we have NABR. Yeah. They are saying to you that determine whether these chemical compounds, they are ionic or molecular. Okay. So remember that ionic substances must always dissolve in water. They must dissolve in water. When they dissolve in water, they will produce ions, all right? They can break up easily, you get what I'm saying? And then they are good conductors of electricity, ions. There is something, guys, we call electrolyte. An electrolyte is a substance that contains free ions and that behaves as a good conductor of electricity. That's what we call an electrolyte. Like, it's a solution that contains free ions. You know? Yeah, that's what you call it. You'll learn it more as we go further with this. All right, so now let's try to identify. If you want to identify, you need to look at your metals. Start with metals. On this compound, do you see a metal? Potassium is a metal which is in group 1. It has a +1 charge. This guy is a polyatomic ion. As I've asked you, go and look at polyatomic ions. It's what you call a nitrate. Remember, we have nitrate and nitrite. Sorry for that. Like this, nitrite, nitrate. There's a difference between the two. So go and learn those polyatomic ions. It's important. And then this guy carries 1. It's easy because look, there is 1, there is 1. Obviously, it means that everyone carries 1 charge. You see, so this guy he's going to be called ionic. Ionic because potassium is a metal, nitrogen is a non-metal, oxygen is also a non-metal. So you're having a metal, basically having a non-metal compound with an element that is a metal. It's going to end at the end of the day, it's going to basically give you an ionic compound or ionic substance. Here, do you see any metal, like any metal? Look at your periodic table. So carbon, hydrogen, oxygen, they are all non-metals. And this guy, it's like your ethanol. This guy is like ethanol. It's like an alcohol. So it's an alcohol, it's an ethanol, which is a molecular. It's a molecular because of they're all non-metals. It's a covalent bond. So this one is going to say it is a molecular. It is a molecular because they are all non-metals, right? And I'm going to tell you something important. And then this guy as well, you can see, still a molecular. Still a molecular. It's like your sugar. It's like your sugar, this one, if I'm not mistaken. It's like your sucrose or sugar. All right? Yeah, those who didn't know, that's how it looks like. And then sodium bromide. You see sodium bromide, which is NaBr. Sodium is a metal. It's a +1 and a -1 charge. You can see 1, 1. At the end of the day, it means +1, -1. Then this guy is in what? Ionic compound or ionic substance. I hope this was able to assist you guys to differentiate between ionic substance and molecular substance. As I've said, molecular, most of them, they are covalent bond. There has to be a non-metal reaction taking place. You get what I'm saying? Like these two. Okay, so now let's try to look at other questions. Let me see. Can I do this one? Yes. Let's do the last ones to identify. Let's do the last ones to identify. Okay. Guys, please, if you have any other questions, feel free to share, Feel free to comment, feel free to say any thoughts you have, you know what I'm saying? Good. And don't forget to subscribe, to like, and to share. Get what I'm saying? Love you guys. Now, here's another one. Number 1, I'm going to use the black marker again. I have this guy, CH4. Number 2, I have, what is this? Okay, I have KBr. Number 3, I have CO2. Number 4, I have LIF. Number 5, I have MgCl2. All right. So the question says, determine whether the substance are ionic or molecular. The second question says, give the chemical names or common names of these compounds or substances. So number 1, let's identify. Is this one an ionic or a molecular? C is a non-metal. H is a non-metal. It's a covalent bond. Since it's a covalent bond, we know that we are dealing with a molecular compound in this case, because molecular compounds, they cannot form ions in a solution. They are like non-electrolytes. They could be those that are weak electrolytes like alcohol. I will show you. All right. So this guy is going to be let's do it. This guy is a what? He's a molecular. He's a molecular compound because all of them are non-metals. Here we have KBr. It's a plus, it's a minus, all of them. Okay, this one I don't want to talk about a plus and minus because I don't want to make things hard for people, because here you must look at the electronegativity to know which one is minus, which one is plus, which in this case, the minus is carbon, the H is going to be the plus. So, but yeah. Okay, so here you can see K is a potassium which comes from metals. You get it? So this one is ionic. CO2, they are still non-metals. What is this one? Molecular. What about this one? Lithium is a metal, non-metal. This becomes what? Ionic bond, ionic substance. Here you have Mg, metal, Cl. So it's a plus, it's a minus, it's a 2 plus, it's a minus. Then you also have what? Ionic compound or ionic substance. Remember that ionic substances, we always have a metal and a non-metal. That's ionic bond, and which will end up giving us ionic substances or ionic compounds, which when they dissolve in water, they will produce ions, and they tend to be good or strong. They tend to be good electrolytes, by the way. They are good conductors of electricity as well. All right. Then molecular, mostly they are non-electrolytes. There could be those ones that are like weak electrolytes, which like acetic acid, body ethanol as well. You get it? So yeah. So the second question was, let's name these compounds that we see here. Let's name them quickly. Let's name them. So this one is called a methane, and this one is gonna be called potassium bromide. Okay, and this one is gonna be called carbon dioxide, and this one is gonna be called lithium fluoride, and then the last one is gonna be called magnesium chloride. I think this one we did it before, yeah, okay, but it's fine. I can just, since the space is small, I can write it here. That one is magnesium, like this, magnesium chloride. So you guys must be able to know the chemical names and the chemical compounds. Some days they could give you this and say, methane, give us the chemical formula. So you must know it's this one. They give you potassium bromide. It's a metal element, a non-metal element, and then there you go. You get it? So you guys must be able to go forward and backwards in chemistry like that. All right. So guys, if you couldn't understand, or you feel like Mr. the decomposer was too fast, please guys, share. Tell me guys, tell me. You better tell me that, okay? And then there is something called CO. CO is called carbon monoxide. The reason why you call it a carbon monoxide is because of there's only one oxygen. Mono means one. That one is CO2, is called carbon dioxide. It's because of there are 2 oxygen atoms. And then CO3, yeah, someone's gonna say because of it's 3, it's carbon trioxide. Back in grade 8, that's how they used to tell you, but there is a better name that we use. We call it a carbonate, okay? Carbonate. All right, I hope you're all good. Guys, please go and study the polyatomic ions, monoatomic ions, diatomic, and then we will be good. Okay? Now, there is the last part I would like to do with you. Where is it? Yeah. We have sodium sulfate, guys, number 1. You are given sodium sulfate. Number 2, you are given potassium bromide. Can I just change and make it maybe potassium chloride? It's fine. Potassium chloride. Excuse me. And then number 3, I have potassium permanganate. Okay, this one I'm going to change it. We have been using a potassium chloride or potassium so much. Ne? Let's change this guy to sodium. It's fine. Let's leave it. So okay, we have sodium. Can I use calcium then? I think calcium is better. Yeah. Calcium chloride, I think is better. And then another one we could have, that's number 4, we have sodium what? Sodium phosphate. Yeah. Okay. Now, what's going to happen here is that you are going to give the chemical formula. Number 1, give a chemical formula for each of the substances here. And then the last part is that you must show the dissociation of these substances. Remember, dissociation is when these substances, they tend to produce the ions in a solution. You get what I'm saying? The moment they are dissolved in water, they will start to break into ions. So we want to see those ions in a solution. That's what we're looking for when they say give the chemical equation of the dissociation of the substances. You gotta do that. Okay, so first of all, let's try to do this. Sodium sulfate. Sodium is basically Na+. Sodium is an element. Sulfate is this guy, SO4 2-. Okay, that's what I'm having so far. And then calcium is basically this guy, 2+. Chloride, you know this is basically chlorine. And then potassium is basically K+. Permanganate, you must go and learn this what you call the polyatomic ions. So this one is going to be MnO. It's Mn, manganese with oxygen 4- like that. So yeah, and then sodium again, and then phosphate is PO4 3-. Okay, so now I had to break, these are the ions in a solution. In the solution, I'm going to have this type of ions. The moment I take this substance and I dissolve it in water, like when you're taking your grandpa, your disprin, your, you know what I'm saying, right? You dissolve them in water. They dissolve, like take a disprin for instance, put it in water, it's going to it shows that it's dissolving. When it dissolves, that substance is going to produce ions. You get what I'm saying? The ions in that chemical compound. If that compound is made of calcium chloride, we're going to have calcium ion, chloride and chlorine ion in a solution. You get it? And they'll all be surrounded by the water molecules. That's the part of what you call hydration. You know? So let's try to give the chemical formula now. Look, guys. So I'm going to have my formula here is going to be Na2SO4. That's what we call sodium sulfate, because the 2 comes from here and the 1, don't forget. Alright? And then here we have calcium chloride. I'm going to have CaCl2. Remember, the calcium has the 2+ and that minus, and then that's what we talk about, what? Ion exchange reaction. Don't forget it. And then we have potassium. This one is going to be KMNO4. So MnO4, it's the same thing. It's a permanganate is basically this MnO4. Potassium is one thing, you get it? So yeah. And then the last one, which is sodium phosphate, which I'm going to write it down for you, is going to be Na3PO4. So the 4 is on oxygen, it's on oxygen. So this is what you call sodium phosphate. The 3 comes from the phosphate, as I've shown you guys. So these are the chemical formulas These are the chemical names. Now we need to do the chemical equation when these guys dissolve in water and produce ions. So basically what we need to see is that if I take this substance and I dissolve it in water, what are the possible ions I'm gonna get? Now check out. Okay. This one is gonna be CNA2SO4. When I dissolve it in water, I'm gonna have sodium ion plus SO4 2 minus. And check what I'm gonna do. Aqueous. Aqueous, it shows that they are dissolved. Aqueous solution, remember water is your solvent. These substances are the solutes. At the end of the day, you have a solution. So it's aqueous because of they are able to can dissolve, because water is a good polar molecule. And then from there, I can show you the one of the calcium chloride. So this is the chemical equation, right? All right. So let's do the one of the calcium chloride. That one of the calcium chloride. That one of the calcium chloride was like CaCl2. So CaCl2, of course it's a salt. This one it's like a salt, okay? It's a salt because it's an ionic compound. And then ionic crystal, if you can put it in that way. When I dissolve it in water, I'm gonna have calcium chloride ion. Calcium ion, and then I'm also gonna have chlorine ion. This is gonna be aqueous. And check something, because here, I think I made a mistake. I'm gonna go back to that one. Check guys, because here there is two chlorine, here there is one. So it has to be balanced, so I must put 2 here. There are two chlorines, one calcium, so it's balanced, okay? That's what you must do. So let's go back to that first one, because I feel like I made a mistake in terms of balancing the equation. The first one was sodium phosphate like this, right? So I'm expecting to see sodium ion plus sulfate ion like that, and then I'm gonna put 2 here. So the 2 shows that there are 2 sodiums in this case, one sulfur, 4 oxygen atoms. So guys, it's balanced. You can see it's balanced. So that's a balanced equation of a dissociation of this substance called sodium sulfate, right? Then let's do the last problems. Which is which is called UKMNO4, your potassium permanganate. So when I dissolve this guy in a water as our solute, I'm going to have ions, which is going to be K plus MnO4 minus. And then don't forget, anything that dissolves in water and produces ions, the phase that we use is aqueous. It's not a gas. Remember, we have S meaning solid phase. Aqueous, it's a phase as well. We have a liquid like your water. It's a phase, like when it's like this, L, it's liquid. And then you also have G, which is like your gas. So yeah, no, aqueous, they basically means that they are dissolvable. They are soluble. And you must also go and learn your solubility rules, because some substances are not soluble in water. They are insoluble, and whenever they are insoluble, they tend to form what you call a precipitate. Precipitation reaction is a reaction in which a substance tends to be insoluble. You get it? And then an insoluble substance, we call it a solid substance. That's a precipitate. All right, so this one is balanced. We move on. All right, then the last one is going to be called your sodium phosphate. I'm going to do it nicely with you, don't worry. Okay, so this one is yours. Okay, the marker is not really that strong. I cannot use it. So I have this guy, right? Yeah. So let's see something. How can you do this one? Dissolve this guy in water. He's going to give you sodium ion plus plus phosphate ion. You get? And then you put it in an aqueous, of course, because they were able to produce ions in a solution. And then now you can balance. You have 3. I'm gonna put 3. I have 1. Everything is the same. So it's a balanced equation of a dissociation of sodium phosphate. If you guys have any other questions regarding how to identify ionic substance and a molecular substance or a covalent bond, ionic bond, feel free to share, feel free to comment. Bafethu. The goal is to assist each other, to help each other out. Guys, I'm doing these videos because some people cannot be able to get an access of me, like physical and stuff. They wish they could because I get calls and stuff. So the best thing you can do is to try to watch my videos on YouTube, on TikTok as James the Decomposer and the Synthesizer. For math, physics, chemistry, I am there. Share anything, guys, any questions you have, if as well, because I know some are gonna write trials, the exams, final exams are coming soon. Some are doing the writing test. If you have questions, feel free, guys, to let me know, and then I can be able to help you. We can also go live on here on YouTube and we work together. We go live on TikTok. Get what I'm saying? We work together. We decompose and we synthesize new ways. God bless, Bafethu. This is all I have for you regarding the ionic substance and the molecular substance. You get what I'm saying? All the best. Thank you, guys. I hope you guys were able to enjoy this video and we're also able to learn stuff here. Okay, all the best.